Okay, we're going to go ahead and take a look at the empirical rule and Chebychev's theorem. So first of all, we're going to build the normal curve. This you should be familiar with from Algebra 2, but in case you've forgotten, we're going to go over it. Okay, so whenever you're building a normal curve, okay, you always start with the mean and use the standard deviation. So really what we're going to talk about is the amount of data within the number of standard deviations in the means. Now, your percents are the empirical rule, and pretty much what you need to memorize is this: the 68, 95, 99.7. Okay, so first of all, you start within one standard deviation of the mean. That's going to be 68%. Okay, 2 standard deviations of the mean, 95, and 3 standard deviations of the mean is 99.7. So maybe you want to just kind of make yourself a little note there. This is 1, this is 2 standard deviations, and then this is 3. So what we're going to do now is we're going to build this normal curve and look at the percents. So I'm going to give you the mean. I'm going to use the symbol for population mean, which is 77. And then I'm going to give you, go with the standard deviation, which is 2. A lot of times how you will see this written is they will tell you it's normal with the mean and a standard deviation, and they're just going to put it in that order. So like the direction said, you start with the mean, and the mean is the middle. Okay, each of these marks symbolizes a standard deviation away from the mean. So I'm going to start by moving to the right. One standard deviation would be 77 plus 2, which is 79. 81, and this third one would be 83. Now to go the other way, one standard deviation below, I'm going to subtract. So this would be 75, 73, and 71. So the idea here, I've got my mean that's in the middle. There's the amount of data within one standard deviation, within 2, and more than 3. So within one standard deviation, I'm going to grab some highlighters here. Within one standard deviation would be this right here. That's going to be 68% of the data. So 68% of the data is within here and here. So if I take 68 divided by 2, I'm going to have 34 on both sides. Okay, so we could kind of go ahead and say from here to here is 68%. Now, if I want to talk about 95%, 95% of the data is within 2 standard deviations of the mean. So there's 2 standard deviations right there. So again, I can say 95 goes from here to there. Now, if I want those little sections, what I can do is take the 95 minus the 68 and divide that by 2. When I do that in each of these little sections, it's going to be 13.5%. 8% of the data, 34 on each side. In the yellow, 95% of the data. So in these sections, to get the 13.5, I did the 95 minus the 68, and I divided it 2 because this is a symmetrical curve. Okay, and then the last percent was the 99.7. So got that right here. 99.7. That is going to be from there to there. And I can go ahead and write in that from this little end to there is approximately 99.7% of the data. So you'll notice there's going to be 3/10 on the outside. But then to get those little numbers there, again, you can just take the 99.7 minus the 95. Since it's symmetrical, you divide it by 2. So here I'm going to have 2.35. And here is also going to be 2.35. And generally the curve ends there. If I wanted to, I could put the little 0.15s out there. That would be the 0.3 divided by 2. Okay, so what we have here, we've set up a picture of what our empirical rule is. And I would recommend drawing this curve anytime you're given a mean and a standard deviation and you know the data is approximately normal. Okay, this is the empirical rule. So now we have a question to go with it. It says, what percent of the people fall between 73 and 79? So the probability that it's between 73 and 79. Okay, so 73 is here, 79 is here. So pretty much I just need to add up those percents. 13.5 plus 34 plus 34. So I'm going to have 68 plus 13.5. And so that's going to be about 81.5%. Okay, now we will be doing some questions in class, like they might say, what is the interval for 95% of the data? That would just be 2 standard deviations of the mean. Okay, so let's just do a little summary here for the empirical rule. For 68%, to get that interval, that's going to be the mean minus the standard deviation and the mean plus the standard deviation. For 95%, it's going to be the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. And then we'll do the same thing over here for 99.7% of the data. That's going to be the mean minus 3 times the standard deviation and the mean plus 3 times the standard deviation. Okay, and we'll do some examples with those in a minute. Now, before we go on, we need to talk about Chebychev's theorem. Chebychev's theorem works for all data. So you don't have to know that it's approximately normal. So if nothing's known about the data, you would use Chebychev's theorem. So for Chebychev's theorem, this is the formula right here. Take 100, k squared, where k is the number of standard deviations. Okay, so I'm just going to zoom out just a little bit to make sure you can see all that. So that's Chebychev's theorem. So if I ask the question, what percent of the data falls within 2 standard deviations of the mean? Mean, assuming nothing about the data, so you can't assume it's normal. I would just go ahead and plug it into the formula. So for the percent, I'm going to take 100 over 1 minus 1 over 2 squared. That gives me 100 times 1 minus 1/4. And I'm going to have approximately 75% of the data. So those are basically the theorems. Now let's just do a couple quick examples using these.